In this lecture, we're going to address the non-parametric equivalent of the independent samples t-test that was addressed in an earlier unit. And that's going to be the Mann Whitney U test. And the Mann Whitney U test is used to examine statistical differences between two independent samples. And so these represent samples of individuals that were evaluated independent of another group of individuals. So individuals were randomly assigned to two different groups. And in this example, the reaction time to two different colored symbols displayed on a computer screen was evaluated. And each of the one group was assessed for their reaction time to a red symbol, and an independent group, a completely separate group of individuals, were evaluated for their reaction time on a computer screen to a black signal. And the table here illustrates the reaction time in milliseconds. So the lower the number, the better the reaction time. And what we see here is that we have reaction times that are considerably, that at least appear to be considerably faster for the participants that observed a red symbol on the computer screen than the individuals that observed a black symbol on the computer screen. What is then done is that the raw scores are converted into ranks, and so the reaction time of 480 milliseconds is the lowest value, but we assign that a rank of 1 because the lower number indicates a better reaction time. So we would rank that as 1, 540 would be 2, 593. What we see over here in the other group, the participant that had a reaction time of 595 milliseconds ranked as 4. So the rank ordering is not done independently within each group, it's done collectively for all the scores. And then once the ranking is completed, the rankings are summed up vertically, and we see here that the numbers are lower for the red symbol than they are for the black symbol, indicating that we see generally overall that participants were able to react faster to a red symbol than a black symbol. And at this point, with the Mann Whitney U test, after the sum of the ranks are computed, the equations that you see indicated here are then used to calculate two Mann Whitney U test statistics. That would be U1 and U2. And so by inputting the sample size, so we had 5 participants in group 1, 5 participants in group 2, and we sum the ranks for group 1, and likewise we carry out the same mathematical approach, except the only difference is that we work in the summation for the participants in group 2. And so we see a lower U value for U2 than it is for U1. And this is following a similar approach as we've done with all the other statistical tests, is that we're going to eventually compare the Mann Whitney U statistic with a critical value. And that critical value is obtained from the Mann Whitney U table as illustrated on the bottom of the slide. So what needs to be determined is which of those two statistics, the U obtained, is used to compare to the critical value. And so this is a two-tailed test, meaning that it is not directional in nature with respect to the mathematical computations, but we'll eventually be able to arrive at a conclusion with respect to which of the two groups reacted faster to different colored computer symbols. The lower U value of U1 and U2 is selected as the U obtained in this situation. So from slide 18, the lower of the two values was U2 at 2.0. And then we therefore have to then go to the Mann Whitney U table to find the critical U value. And so being a two-tailed test, this does not indicate directly whether it's greater or less than, just that there is going to be a significant difference. So what we see here is the alpha level, and unless stated otherwise, we always go with 0.05. We have the number of participants in the first group, and we have the number of participants along the vertical column in the second group. Recall, the Mann Whitney U test only compares two groups. So we see that in the second group we had 5 scores, or 5 participants. We had 5 scores, or 5 participants in the first group. And going with the 0.05 level, we see that we have a critical U value of 2. We then compare the critical value to the obtained value. And this is going to be a little bit different here, whereas we typically, our typical retain rejection rule always states that the obtained value is greater than or equal to the critical value. For the Mann Whitney U test, it's reversed. So if the U obtained, which is the lower of the two U values calculated on slide 18, it is significant if it's less than or equal to the critical U2 value. And so, just the U critical value. And so since the U obtained had a value of 2.0, the critical value was 2.0, we see that although it's not less than, it is equal to the critical value. So we therefore determine that the two groups are statistically different from each other. So the smaller the U obtained, the more likely that the null hypothesis is false, and we're likely going to reject that null hypothesis. And so in this situation, if significant, and given that the obtained U value, 2.0, was equal to the critical U value, the results were statistically significant. And so the samples of reaction times here in this case represent different populations, or rather that the reaction to a red stimulus is significantly faster than a black stimulus when it is on a computer screen. So this ends this lecture on the Mann Whitney U test.